Hello and welcome back to another episode of the MAT Livestream. My name's James Munro. You're watching Primes and Proof this week. Good to have you with us. Hi to everyone watching at home. If you want to join live chat over in Slido, you can do that by going to the URL at the bottom of the screen there, which is something like slido.com/matlive, MATLIVE. Hi again to Chris and Harriet and some anonymous people. Denim's here, I've seen Rebel and JWC. Oh look, there's a person who says Physics Girl here for fun. You don't have to use your real name on Slido. You can put in some sort of description of why you're here if you like. A couple of people who are new to Slido, so it's good to have people here in who are new there. If it's your first time watching the live stream, the way it works is this. We've got a worksheet. It's on the screen. You can also download a copy at the link at the bottom there, /r/matlive on the maths website. If you do that, then you can get ahead of this live stream. If you feel that we're going too slowly, you can read ahead. If you want to see what's going on next week, you can download next week's worksheet as well. If you want to get the answers without watching this, then you can get those on the website as well. But the point of doing a live stream is that we can chat about stuff and that we can go through stuff maybe a bit more slowly. So we can go through some of the questions at our own pace. Hi to username Garfield there. I am having a good day, I think, a good afternoon. If that question was aimed at me, if not, then never mind. Sorry for sharing. Kai asks, are we going to prove Fairmont's last theorem? Unfortunately not. Good. Everyone else is doing well. Oh yeah, let's do the poll. So we'll do the answer to that question about admission standards, but let's do the poll. We like a poll. Poll's good. So we tend to do a poll to find out how your day's going, rated on a 5-star rating from 1 to 5. There was a question there in the Q&A about applying to Cambridge. Can't tell you much about applying to Cambridge because I don't work for Cambridge, but I can tell you about Oxford. They wanted to know if there are different chances for if you apply at different colleges, and especially my day job, to make sure that that's not the case. But whichever college you apply to at Oxford for maths, you've got the same chance of being made an offer. I run lots of behind the scenes processes to make sure that we're comparing applicants at colleges. We've got a shared database. I don't know if Cambridge do this, but we've got a shared database here where we put all the applicants together in a shared database so we can see all of them at once. I did apply for Cambridge, that's true. Kai's pointed that in chat. Applying for Cambridge doesn't mean I know what database setup they have behind the scenes. And also I applied a very long time ago. Chat, what is going on? Chat's, I think, not having a great day or something. There's lots of people voting for 3 stars, which is, that's solid middle of the road meh kind of day. As always, I'm looking out for the small number of people who have voted for 1 and 2 who are not having a great day. Maybe some primes and proof is what you need. Goodness me. People liked one of the jokes. There's appreciation for one joke in chat, which is good news. That joke can stay. How many pencils? I think you're allowed to bring in pencils. It's not recommended that you write in pencil. There's an instruction on the front that says please use a pen. The MAT papers this year, 22, are going to get scanned in by a machine. They're going to get scanned, and then we're going to mark the things that the scanner sees. We do have the technology to go and get the physical papers if we have to, but if we can't read it, then it's a bit harder to do. Please write legibly. Okay, I think I managed to do that correctly. Open days. Any disadvantages? Oh yeah, Elena's asked about open applications. So let's do that now because I think people are applying right now. 3.6. It's not a great day, is it? Not a great day. Yeah, we've had better than 3.6. Elena's here has asked about open applications, which is fine. I have a mathematician way to explain open applications, which is if you make one, then a computer algorithm will randomly, not uniformly randomly, but will randomly assign you to a college. And then you're treated exactly as if you applied to that college. So if you're a mathematician, you know about random numbers, you can simulate that for yourself by rolling some dice or something and picking yourself a random college. The advantage of doing it yourself is that then you can re-roll the dice if you want to. You might discover you have some opinions that you can re-roll and do it again. So there's no advantage to doing an open application because you get given a college and then treated just like you applied to that college. You don't get any extra steps of process. You don't get considered by extra colleges or something. You just get a computer assigns you to a college, and you can run the process yourself if you want to. If you really want me to roll the dice, then you can put or my computer to roll the dice. Then you can put it in an open application, and we'll sort that out by giving you a college. It is, I think everything is pseudo-random in some sense. That's a philosophy question. Is there such thing as a random process? Is random? You're supposed to use the paper in the booklet, which is again a scanning thing. Our general policy, I suppose, is that if we receive work and we can read it, we'll make our best effort to read what we've received, and we will try and give people marks that they deserve. You can make this easier for us by writing in the booklet and by using pen. Got any mods today? I think I do. I think I've got Prisma. I've stopped clicking, and things are still getting approved in chat, so I think Prisma's here. Yeah, it's happening. Here we go. Jack wants to ask for me to specifically roll a dice. No. Okay, right, fine. That metaphor got out of hand. XY's at 2 out of 10. Colin Fleet, I was ill last week. It's horrible, isn't it? And yeah, just couldn't get anything done at all. You're not really supposed to. Yeah, not supposed to run out of space. There's also the other. Everyone's got 2 questions they're not attempting. If you're a maths candidate, you're not attempting questions 6 and 7. They come with blank space, which is free real estate that you can use to answer your questions as well. Anything you write in the booklet. I'm going to prove that. I'm going to prove something about logarithms. Oh, it's from my logarithm proof. Some manipulation with logarithms. Probably not. Did I write it out with luns? I can't remember if I'm supposed to use luns or not. Long questions for computer science. Yeah. Computer scientists do long questions number 2, 5, 6, and 7 for computer science applicants. So there's these special 6 and 7 questions at the end that are written by the computer science department that computer science applicants take. They're slightly different long questions. We're going to do some question 6 and 7 stuff, maybe some question 5 stuff, question 5, 6, 7 stuff next week in an episode called Recursion, where I've got a volunteer from the computer science department along, a current student. You're going to like them. Yeah. Sadness in chat for being sick as a concept. Well, shall I do the maths and stats question? I don't really know how I feel about the maths and stats question. So lots of people compare the maths and stats statistic for admissions against the maths statistic, assuming that the applicant pools are exactly the same, and that's not true. They're different people, at least, because nobody applies for both. They're different people, and we're looking for the same standard of mathematician in the process. Good. Yep. Recursion's next week. We'll do the recursion jokes. Save the recursion jokes for next week. I think, did I put it? We'll save it for next week. Zach's already put in a really early request for question 10 on the warm-up. If you're new to the live stream, we do skip some of the warm-up. It's not a great warm-up practice. Well, not great warm-up in general, right? If you're skipping things. Oh, hello. How do I get that to go away? There we go. Good. Okay. There's a question about algorithms for shortlisting. Not so much. So computer science, I know, have tried some statistics. We had some shortlisting statistic. We've never done our shortlisting with an algorithm that tells us what we have to do. We've sometimes calculated some statistics that help us make decisions, but we've already made those decisions with humans. There was a time recently that statistics seemed to have got rebranded as machine learning and then suddenly become unfashionable again. So, goodness knows. Zach, I don't know what second order recursion is. Let's save it for the recursion episode. Let's ask the computer scientist. Hopefully they will know about recursion. Okay, people are excited that there's a recursion episode coming up, which makes me think that people aren't looking at the list of episodes, which is available on the MAT Live website, but there's only a couple left, so this is not a great time for me to advertise the schedule of content. It's probably a good time for me to do some content. Should we talk about proof? Rebels used Fermat's last theorem on one of my warm-up questions. That's pretty exciting. Ross wants to know the average MAT score. Average MAT scores are available on the MAT website for previous years. You can check out the average score of people who applied and the average score of people we shortlisted. Stats like that are on the MAT website, which you can get to. It's on screen, but if you cross out LIVE and you just go to /r/MAT, that takes you to the big MAT page with statistics. Good, right, maths. question for question 4, and I think somebody asked about Wilson. Oh, love a good bit of Wilson's theorem. Question 4 of the warm-up, which we're going to get to. But get your requests in. Oh, I love a good proof. If you hear some loud noises, I think there's somebody outside. I find this very funny. There's somebody outside my office doing scooter tricks. I thought it was skateboarding and therefore cool, but it's not a child. It's a grown-up on a scooter doing their best attempt at scooter tricks. So sorry if you hear some background noise. It's possibly the only thing in Oxford that's less cool than this live stream right now. Okay, so divisors and prime numbers. Let's go for that first. A whole number is a divisor if you can write it like this. If there's some other number k, I love this definition, some other number of k that you can multiply the divisor by to get up to that number. So that's how divisors work. I think I'm going to stick to positive numbers today to avoid tricky questions about negative numbers and units. So we're going to, maybe I should put positive somewhere on this screen and say, oh gosh, I only feel like talking about positive numbers right now. So for example, my prime number definition that I'm using, I guess restricts down to positive things by saying greater than 1. I quite like this because it restricts to positive numbers at the same time as ruling out the is 1 prime kind of question. And prime numbers, prime numbers, they're the ones that have no non-trivial divisors. All numbers that have 1 in themselves as divisors, I suppose, but for prime numbers, that's it. It's a good idea to know a few examples of prime numbers. You probably do know some, but it's maybe a good idea to know a few. I know how many prime numbers do I know? Let's try and find out. Here are some primes, and I'm going to keep going until I get bored. 15 is not prime. You see, now I sort of veer into working out prime numbers. Yeah, I think I'm going to stop there because I'm thinking too hard now. But maybe having some ideas about some prime numbers might be a good way to check some facts about prime numbers. Later on in the warm-up, we've got a question about prime numbers, and we might want to try it for some small prime numbers. Checking facts for small numbers is a good idea. Somebody in chat is going to tell me that I've written either a number that isn't prime, or I've missed one that is prime. So the danger of trying to write down primes at the same time as thinking about primes and talking. Right, good. Rational and irrational numbers. We sometimes use these words in math questions. I hope they make sense. I don't really know when you learn about rational and irrational numbers in school. Probably depends on school systems, doesn't it? But if you know about rational numbers, they're fractions, right? I should probably stack that up more nicely. There we go. Sort of P over Q, like that. Where P and Q are whole numbers. Sometimes we talk about it being in lowest terms if these numbers don't have any common factors or common divisors. And irrational numbers are anything that's not rational. It may be surprising that there are such things as numbers that aren't rational, but at some point we'll meet some proofs that there are some numbers that aren't rational. Question 2, yeah, question 2, request for question 2. Let's mark it down. Mark it down. Oh yeah, question 2. Question 2 is brilliant. I put a proof in the warm-up that I'm not going to go through now. Proof in the warm-up that there is such a thing as an irrational number. It's something that someone showed me at university. One of my tutors at university showed me this, as they claimed the easiest number to prove is irrational, which they said is this number, log 2 over log 3, using natural logarithms, but it doesn't really matter. The proof is really nice. It's got this nice even odd step at the end, and it turns out that if you think it's a rational number, P over Q, then nonsense follows. There's a standard proof by, it's a proof by contradiction. There's a more standard proof that you might have seen that root 2 is irrational. I guess we'll hit this up when we do question 4 in the warm-up. There's one that people are normally shown at some point, I think, that the square root of 2 is also an irrational number. We'll get there when we get there. General tip about even numbers. Really don't know when I learned this, but it's sometimes a good trick if you know something's even to give it a name like this. So if you know that n is even, to explicitly call that out by giving half of it a name, and you know that's a whole number, m. And then sometimes you rewrite stuff and the twos all cancel out and everything's nice. This is just like a nice thing you're allowed to write down whenever you've got an even number. Pick a new letter. Doesn't have to be M. Doesn't have to be M. Pick a new letter, and that's something you can give a name to and say that's a whole number. And there's a similar trick. If it's odd, you can write it like this. So you're introducing a new letter. Maybe you can translate your problem that was about N into a new problem that's about M. These aren't true at the same time, right? And if you've got multiple numbers, you might need to pick different letters because they might not all be the same. If you've got an even number and an odd number, you might not be able to write down M for both of them because you'd be saying that they differ by 1. What was the last step of that log 2 over log 3 proof? Oh, did I do some maths really quickly? I do that quite a lot. What was the last step? There's some rearranging. Let's do the proof. Suppose that it's a rational number, P over Q. That's pretty standard. First line of a proof by contradiction. To prove that something's irrational is first suppose that it's rational and write that down. Give it a name. Bringing letters in is a good idea because you're giving a name to this. This is in words, a rational number. Okay, but giving it variables, some maths down for what that means, is usually a good idea. I can rearrange it to multiply it by Q and multiply it by log 3. The Q goes up here and the log 3 goes up here. So we get a Q log 2 is P log 3. But by the laws of logarithms, I can do e to the power of both sides and then do some rearranging. So write that left-hand side as e to the ln 2 to the Q, e to the ln 3 to the P. Oh, have I got my P's and Q's the wrong way around? I got my P's and Q's the wrong way around. I have got my P's and Q's the wrong way around. Ooh dear, there we go. Fixed. Note for the notes. Is this the thing someone before we went live said, can you prove that step in particular? And they were trying to trap me because they already knew it was a problem. Maybe I've been trapped. Or maybe I just make mistakes. Left hand side is even and the right hand side is odd. Maybe my PQ mistake doesn't seem to matter that much. It's even because it's some sort of power of 2. Right hand side is some sort of power of 3. They don't agree very much. Good. Okay. So this is proof by contradiction to say that the first line, the supposition we had at the start, must be false. I love proof by contradiction. It's really good sort of strategy. If this is the first one you've seen, then forget all of the details about logarithms and all the stuff about rational and irrational numbers. This structure of what would happen if the opposite, and you have to make sure they're truly opposites. All numbers are irrational or rational, so these are opposites, mutually exclusive opposites. What would happen if the opposite were true? Nonsense would follow. We'd end up with this thing where an odd number was equal to an even number. Nonsense. Okay. Sorry, Ben. Oh, I've got everyone. And then the anonymous person is like, also maybe that's what they were getting confused by. Ah, dear. P's and Q's. Mind your P's and Q's. Okay. If it's your first time watching the live stream, we're not always correct. Not everything. It's possible that I may make some mistakes. Back to the odd and even thing. These numbers are even, these numbers are odd. Sometimes if you're doing a problem that's got some multiples of 3 in, I just saw a question in chat, what was the point of this 3 stuff? What's the benefit? Chris asked, what's the benefit of using 3m? So this is not an odd even thing. This is a totally different concept. This concept of things either being odd or even is sometimes called parity, which is quite an important concept. It's this thing you've met before about whether things are odd or even. You know lots of rules about like odd plus odd is equal to even, odd plus even is odd, even plus even is even. But there's nothing that special about the role of the number 2 here. You can extend to think about how all numbers fall into one of these 3 categories. Oh my goodness, can I write down the numbers correctly? If we reach the new low, there we go, the numbers to 10. This is called, so this is 2 mutually exclusive things. This is an example of a dichotomy. this set of three mutually exclusive things is an example of something called a trichotomy. Tri like three, trichotomy. Splitting things into three groups like this. The numbers that are multiples of 3, the numbers that are one more than a multiple of 3, and down here the numbers that are two more than a multiple of 3. You could alternatively, you could write 3m minus 1 for that set of numbers. Something a little bit weird going on there. Not the same m. In fact, none of these m's are really the same thing. Okay. Can negative Garfield wants to know about negative numbers? I should maybe have made it more clear that I only wanted to talk about positive numbers today. You can extend the concept of what it means to be a prime number. You can extend that to negative numbers, and not much goes wrong. You need to be careful about how you feel about the number minus 1. Now, you remember we don't count 1 as a prime number, and it's a good idea if you don't count minus 1 either. That one should not count as a prime. And then not much else goes wrong. You have to write down very carefully what you mean by primes, because 3 is equal to minus 1 times minus 3, but still feels quite prime to me. You end up with, I think the numbers that are negative look like prime numbers. That's still prime in that definition. The fun thing is that you can move prime numbers to the complex world. If you look at numbers of the form a plus bi, you can develop a theory of what it means to be prime for those numbers, and that set of primes is very interesting indeed. There is an Oxford Online Maths Club. This is a tangent, you can tell, because it's about complex numbers. Complex numbers are not on the maths syllabus. There's an Oxford Online Maths Club episode called Prime Time with Itiad. That is on /r/club on the maths website. So same sort of website. www.r/club episode of Prime Time, which looks at concepts of prime over the complex numbers. You might like it. Anyway, if you like complex numbers and you like primes, both of those are the same thing. Yeah, I got the complex numbers, 21 minutes in, but I pressed the complex numbers button. I got there first. That's my new thing. Harriet's seen that Maths Club episode today. Gaussian integers. It's a really fun set. The map of where the primes are in the Argand diagram is really nice. Anyway, I've got distracted, which does happen quite a lot if you're new here. Mission, don't mention complex numbers. Failed. Mission failed successfully. Negative prime numbers are not on the map. I don't think that's a very normal thing to do. And it takes a lot of setting up because you have to explain that minus 1's not prime, which is like explaining that 1's not prime, but no. Anyway, counterexamples I think make sense. I've become aware that if you're interested in kind of logic and proof, there's a different maths exam called the TMUA, that has quite a lot of logic and proof. It's got this, I think I've shown it on the stream before, it's got this document about logic and proof. So if you search for TMA logic and proof, there's got lots more stuff if you're interested in the kind of language of counterexamples and the ways to do other stuff. 50-50 on maths and stats. I've applied for maths, okay. Almost every college does maths and statistics. I think there's only 2 that don't, and historically they've also considered switching people over to maths and stats sometimes. It's not, I'd say it is not a disaster. Anyway, does the trichotomy go for all values of x? Yes, Chris. It's brilliant, isn't it? You've just invented something called modular arithmetic. Chris, this is a note for Chris only. Nobody tell Chris. Write down what you mean. Well, you kind of already have, right? xm. Yeah, you want integer numbers, but yeah, you can write things as 4m, 4m plus 1, 4m plus 2, 4m plus 3. I'd like you to find out what happens if you take one number in here. These m's might be different. There might be m, n, k, p or something. 4 different letters, right? Because they might be different, might not be the same m. I'd like to find out what happens when you add or multiply these. If you take things from maybe the same class or maybe different classes, and you try adding or multiplying them, what happens? What class do you end up in? Yeah, everyone else but Chris. Yeah, okay, good. Is Matt a be or a end all? A be or no? Wait, hang on. Let me pass that question again. Is Matt be or end all? It's an important thing for being shortlisted for Oxford Maths at Oxford, but that is not the end all. Every year, thousands of people don't go to Oxford to do mathematics, and I think have a lovely time anyway. Good, right. Not the end of the world, even if we don't go to Oxford. Okay. Counterexamples is, I don't know, I'm not going to read this out because it's silly. And I wouldn't want this stream to get silly now. Necessary and sufficient is a little bit tricky. Everyone seems to find this difficult. I changed the notes a little bit. I'm unhappy with what I wrote in last year's notes, so this got updated for this year. So sometimes people try to do word examples. I'm not that keen on the word examples. Let's do something really close to everyone's hearts, which is the squaring numbers thing. Let's say that I've got statements P and Q. Is the statement x is bigger than 1, and Q is this statement x squared bigger than 1. I'm putting quote marks around them to try and be like that's my statement. I'm not really claiming it's true or false. I suppose it's sort of maybe this is true, maybe it's false. Depends what x is, right? Whether this is true or false depends on the value of x. I'm not claiming it's true for all x because that would be nonsense. I've also put a little colon to separate out the name of this statement P and the name of that statement Q. Mathematicians love giving things short names. Anyway, I've got this statement, I give it the name P and Q. I think that P is sufficient for Q because if x is greater than 1, if P, then x squared, what am I going to write down? X times x is bigger than 1 times x, because x is positive, is bigger than 1 times 1 because x is positive again, which is 1. So x squared is bigger than 1. Okay, but laboured proof that's not really interesting right now. But if P, then Q. It's kind of not interesting at this stage. It's not interesting that minus 3 squares the 9. It's not relevant. It's not the case that P is necessary for Q. This is the bit where that fact becomes relevant if you try to think about whether P is necessary for Q. P is not necessary for Q. Because if Q is true, P doesn't have to be true. It might be true, but it doesn't have to be true. If Q is true, the number might be minus 3, which is not bigger than 1. Okay. Ooh. Yeah, P isn't necessary for Q. Why no fast track? Sorry. It's complicated to teach. It's probably the best answer, right? That's just what we've got. Nicholas has put a question in chat about quadrilaterals, which is partly a test of necessary and sufficient understanding, and I think is also a geometry question about remembering what a parallelogram is for starters. Let's try and do Nicholas's question. I don't want this to be a start of some sort of request to do my homework sort of thing. Why does it start at 10? Is it question 10 from my sheet? It's not my question 10, is it? That would be a bit... You can't trick me into doing my own questions. They've got P, Q, R, S, labelled anti-clockwise, which is the sensible way. Necessary but not sufficient condition. Oh my goodness. So necessary but not sufficient. Let me think. So parallelograms, what do I know about parallelograms? I know that they have parallel sides that are the same length. So if parallelogram, which ones of Nicholas's statements? Oh, it's from Tamua. Okay, let's do a Tamua question. Pinned. Which ones of these? Which ones of these are true? Oh, it's got unpinned. Thought it would stick. Ping. PQ is equal to RS. That would be true. And PS is parallel to. Oh my goodness. and PS parallel to QR, that's true. B, PQ equals SR, and PQ is parallel to SR. That one would be true as well. This is going well so far. They're all true. PQ equals QR equals SR equals P. That doesn't, not necessarily. That was not necessarily true because parallelograms can be longer than they are wide. And option D is just PR equals QS. Which I think is, oh gosh, is that true? No, because it could be a parallelogram like this, right? Like the Oxford rhombus is an example of a parallelogram, and it doesn't have equal diagonals. So that's just false. Okay, which one do I want? Necessary, but not sufficient. So I'm looking for a condition which is necessary. The first two are necessary for this to be a parallelogram, but the question asks us which one is not sufficient. Let's think about which one is sufficient for it to be a parallelogram. So if this first one is true, if this, I think we're going to find that one of these you're definitely a parallelogram, and the other one you might be a parallelogram, but you might not, and then we'll pick that one, and we'll be good, I think. Goodness me, why am I doing a Tamura question? Can't really remember. It seemed like a good idea at the time. Those things are equal lengths, and these things are parallel. No, that sounds like one of these. I was trying to imagine it, right? That the lengths are equal. The lengths are equal, and then PS. I'm trying to imagine these being parallel like this, right? Could be this. So that one is necessary but not sufficient, I think. Is it A? I'm going to go for A. With one reply. It's just one reply. It's just a question about Tamura. Good. Right. Cool. Okay. If not, the other one. I don't know if that was helpful because I don't know if I got the right answer, and I'm really, really scared. Right. Good. Okay. Let's do some warm-up questions. It was A. Oh, it was A. Oh. Jack's trying to trick me into doing one of my questions, which, you know, I've approved the chat message, but I don't like this. Okay, warm-up. We've got some requests. If you want other warm-up questions, put a request for question number in chat. If you just shout a number in chat, I'm likely to forget what you meant, being a forgetful person. So first two questions are kind of the same joke. The first one is I hope, obviously, difference of two squares, which is one of the greatest A-level algebra facts, I suppose. You can factorize this. So it doesn't look like a prime. Doesn't look prime because we factorized it. Here are some factors, some divisors of this number. Oh, except if one of these is 1. And actually that does sort of work out a little bit. That gives you the prime number 4 minus 1, which is 3, and it gives you the number 0 squared minus 1, which is -1, which we're not thinking about right now. So this is not, no, okay. Oh, request for 9 and 10. If you're ill for the mat, yeah, always let your college know. Letting your college know is a good idea. This is my sneaky first question in difference of two squares. Love difference of two squares. Stop! I'm not trying to stay on. The topic is somewhere around. Sneaky difference of two squares. The second one is also sneaky difference of two squares, because n to the 4 is also square. It's the square of n squared. Oh, did I get you? This actually factorizes again. Look, because this n squared minus 4 is also the difference of two squares over there. So this really doesn't look prime. This is not prime unless n minus 2 is 1 or n plus 2 is 1. One of these things need to be 1. N squared plus 4, could that be 1? And that one actually doesn't work at all. That one gives n equals -1, which I'm not really interested in right now. And this one gives n equals 3, which gives the, is this prime? Is this prime? I think it's not, because it ends in a 5. 65, isn't it? So I think no. Not very good. Yeah. Right, good, okay. Laughing in chat, good. Prime numbers are prime numbers are not that hard to find. There's surprisingly many of them. Let's not go off topic. So is this classic proof for 4? I've seen some requests for, let's write them down while they're coming in. Lots of flags. 9 and 10, all of them. Okay. And they're 9, okay. 9 and 10. I think I saw a vote for 8. I should get to all of them. I'm just going to do all of them. I like these questions. Nobody's asked for 3, which is a variant on the proof that I think you've maybe seen about square root of 2 being irrational. Let's do question 4 instead. Let's not do all of them. Having just said I'd do all of them. Because I think this one includes some interesting stuff that will help you with question 3 as well. So suppose this is rational. Suppose it's P over Q. Then, I don't really know much about the nth root of 2, except that I could do this. I could raise both sides to the power of n. And 2 would be p to the n over q to the n. And then I could multiply up. 2 times q to the n would be p to the n. So p to the n is even. So, big star, p is even. It's worth being careful with this step. I put a little star, which goes down here. Careful. So p is even. So write p. We can write p is 2 times m, using that trick that once you know something's even, you can write down it's 2 times something else. Plug it back in, and you get 2q to the n equals 2 to the n m to the n. Oh my goodness, a lot of letters going on now. N's bigger than 1. Divide by 2. We get, q to the n equals 2 to the n minus 1 m to the n. So q is even. Oops. We've got a fraction now where we can divide the top and bottom by 2, and then we can run the argument again, and we can divide the top and bottom by 2 again, and we can keep doing it. That's not possible for fractions, for you to keep being able to divide the top and bottom by 2 forever. That doesn't make any sense, so that's a contradiction. You can't do that. Is it enough to say p is even? Do you need to do any more explaining? I would strongly recommend, if you're doing this proof yourself at home, I would strongly recommend for you to at least think carefully about that step with the star to say p is even. If not, then here's question 4.5, I suppose. When is the nth root of 4 irrational? So if I change the number 2 to 4, then the answer changes. It's not always irrational. And the proof has got to break at some point. If you try and copy out the same proof, then it breaks at that step marked star. That's the bit where it breaks. So this step is really important. It's kind of capturing the fact that this thing works. Okay, do I prefer pure or applied? Let's ask people in chat instead. Replies are on. People in chat can say, I'm an applied mathematician. I did an entire PhD on fluid dynamics and the mathematics of fluid dynamics. Okay, it does break when n equals 2. Yes. Good. Okay. True. So where does the proof break? When it, because if you replace all the 2's with 4's, and somehow it breaks somewhere. Worth playing around with. Trying to prove things that aren't true is sometimes helpful. So trying to prove that this is rational for all values of n bigger than 1 is sometimes helpful because you know it's not true. It's going to break at some point, but if you can spot the point where it breaks, that's helpful. I know that TMUA has some examples where you look at somebody else's work and you look at some imagined students' imaginary work and you find out where the mistake is. Seems like fun. Do I know what a Klein bottle is? My Klein bottle's at home. I wish I could just pick up my Klein bottle and show you. No, I have no idea what it is. That'd be such a good joke. Unfortunately, my Klein bottle is at home. Good. What's the star? Oh, the star is a little footnote to say, oh, watch out. Maybe it shouldn't be a star. Maybe it should be something that more. So star would be like good thing, right? Because stars are good. It should be like a wobbly face. Okay, I think that still works as a footnote. Good, okay. Little brackets because I want to move on. P is even. P is even, but in brackets. Ugh. Be careful. There's something going on there. Good. Is calculus maths or engineering? Depends what you're doing with it, right? Depends what you're doing with it. Pretty sure it's mathematics though. 6 is famous in some sense. I mean, what does famous maths actually mean? It means you saw it one time and then you remember it. And for me, I saw this one time and now I remember it. There is a counterexample to the claim that it's always prime. If you start plugging in small numbers, it works for a surprisingly long time. You get 43. When you plug in n equals 2, you get 4, and 2 is 6. It's 47, which is pretty good. So you're pretty happy. This is generating prime numbers. It'd be pretty good if this always generated prime numbers, but it doesn't. It breaks when n is 41. You get 41 squared plus 41 plus 41, which is a multiple of, you guessed it, 41. So it breaks. And I can't remember, I don't think it breaks in between. I think it's really cool that it gives you lots of stuff. And it gives you other things along the way. In chat, 40 is also an example apparently. Let me quickly think about 40. Yeah, because it's 40 times 41, isn't it? 40 and an extra n. Yeah, this is n times n plus 1. So then it's, okay. 40 also breaks it. But less obviously. Does it break for n bigger than 41 is a great question in chat. The answer is yes, otherwise you'd have heard of this. If this always generated prime numbers, it would be the second thing that people tell you after the definition of prime number. They'd say, prime number has no numbers except for, no factors except for one of itself. Oh, and n squared plus n plus 41 is a good way to generate big prime numbers quickly. So it's not true. In fact, now that you've seen that it fails at 41, you can maybe guess another number that it fails at, which chat is going to tell us in about a second. Yeah, this factor of 41 was a really good idea, because then the n's a multiple of 41, and so are the other things. In fact, that gives you an idea for how to break this style of prime generation for any polynomial you can, with integer coefficients, you can break in a similar way. Yeah, 82 multiples of 41. Yeah, good. Yeah, now you're great at breaking it. And I like that we don't need to calculate 82 squared plus 82 plus 41. It's like I don't really care what the number is. Someone in chat's put minus 41. Like, nice old person. What are they doing? Does it work for minus 41? Whoa. N times n plus 1. Minus 41. Yeah, because it's negative. Okay. I have got the word positive in this question, but I'll allow it. I think that's cool. 123. Yeah, cool. Okay. Multiples of 41. Yeah, always breaks. And some other numbers. Breaks at some other points as well. Very hard question that I don't know the answer to, and I suspect maybe nobody knows the answer to. When does it break? I feel like if we knew the answer to that, then we would write down a slightly better rule for generating prime numbers using this formula, and I don't think that exists. Is it the number before 41 as well? Yeah, I agree. So the formula, if you not factorize it, but if you simplify a little bit, if you write it as n times n plus 1 plus 41, I'm going to write that a little bit more neatly because I've written it very messily. I write that as n times n plus 1 plus 41. Then if n is equal to, Chris is going to love this, sorry Chris, 41m minus 1 for some m. Chris, it's the thing that you invented, where I'm using the number 41 instead of 2 or 3, your thing with x equals 41. Then I can plug that in, and this bracket out here will be 41 minus m, don't care about that really. M plus 1 will be 41m, and on that 41 at the end is a multiple of 41. Brilliant, multiple of 41. Good. Does applied get all the fame? Does applied get all the fame? Applied gets all the fame. Where's my fame? Right, okay, good. Oh, Jamaica. We're getting suggestions for the next country. I think it might just be Jamaica. So 7.5 question, is it just Jamaica? Sort of horrible sub question of what do I mean by country, what do I mean by flag, oh no, what do I mean by blue? This is why we should stick to maths examples for this. Oh, I don't put USA. Is it only Jamaica? So you've got to get through a lot of flags in order to get to this conclusion. So it's your counter example to either some red or some white or some blue on it. Somebody once told me that the Olympic rings contain the colours of all of them. The Olympic rings share a colour with every flag in the world, but it turns out you just need a red ring, a white ring, a blue ring, and a Jamaica ring, which then I suppose would be the other ones. Right. Yeah, so fans of Pakistan, Alabama state flag. Right, these are some good suggestions. Let's have a quick look at Pakistan. Green and white. Yeah. Good idea. Sorry, Pakistan. I think at one point we had some viewers in Pakistan, so I'm really sorry to people watching Pakistan. Alabama. I think the Alabama US state is. I've just googled it. I think it's red and white. Unless we're doing. Oh goodness, we're doing other flags of regions. People are suggesting red, white, and blue flags. They are examples of a flag. So like USA or something is not a counterexample. Because it has got either some red or white or blue on it. It's got all of those. I suppose, as well as maybe feeling a bit iffy about the word country and the word flag and the word blue, maybe I need to feel a little bit iffy about the word either as well, because maybe some people in the chat believe that that's an exclusive either. I don't really know how people feel about that. Oh, Pakistan's got white. Oops, sorry. I forgot I had white in there. Thanks everyone. The repeats are because of the lag. It's not. It's good as well because it means I don't miss it when it comes up. Ooh, Mauritania's got some red on, I think. I suppose what we're looking for is the negation of if you've got either some red or white, some blue. The negation of that is to have no red and no white and no blue. So this question really just says find an example of a country that has a flag with no red, no white, and no blue, and is not as controversial as either. And old Libya flag as well was just green, right? So yeah, that's been suggested in chat as well. What is? Yeah, there we go. Rebel can have the top. There we go. Thumbs ups here for what is a colour. Good. Okay. I sort of think there should be some more. Ooh, that's a really good shout for the Bahamas. Let's put the Bahamas flag on screen and see what people think. How people think about this. Might depend on your screen as well. We can look up the Bahamas, right? Bahamas got kind of greeny blue in there as well. Greeny blue on their flag. Anyway, right, good. Flag chat. It's 10-6. We've got to do some maths. Question 8 is a bit of a classic, actually. I really like this. I sort of remember how it works. Do I remember how this works? So it's difference of two squares again. I love some difference of two squares. Now I suppose that if your prime is bigger than 4, P is odd, and P is not a multiple of 3. Okay, so P is odd, we can write P as 2m plus 1, if we want to, and then this would read something like 2m plus 2, which is brilliant because that's 4 times m plus 1, so I've already proved it's a multiple of 4. 4, big happy face. Always time for vexillology. Arsenal's not a country yet. Right. Is that a threat? Multiples of 3. P is not a multiple of 3, so either. Oh my goodness. I think I'm getting a little bit of lag on my end now, which is making my pen not so good. But we're going to try pressing on. and either way is a multiple of 3. So I've got a 3 and I've got a 4, but 24 is actually 8 times 3, so I need to find another factor of 2. I need to get another factor of 2, and the way to get it is to look really closely at this m plus 1 to say either m is even or odd, either m even or m odd, to write it down as 2k or 2k plus 1, and then you get an extra factor of 2 out of there. That either way, get an extra 2. Extra factor of 2 out of there. Good. Ooh! Bisexual flag has got some blue on it, come on. It's got blue. We're learning colours. We're learning colours. Also not a country. Right. Don't worry, I fell for Pakistan as well. I did a lot of encouragement for the suggestion of Pakistan. What's the tablet? I got a cheap tablet off Amazon. The brand is not an English word. The brand is VEIKK. It was cheap on Amazon. I don't know if it's still the cheapest on Amazon, but there we go. Good. Right. We got onto flags, by the way, because there's a flags question in the warm-up. It's possibly the most fun question we've done, in that it's not maths really at all. Anyway, it's definitely generated the most discussion, which is one way to measure it. We had some requests for binary here. I put some binary stuff on because I just think it's fun. I really don't know when people learn about binary. You can write numbers in binary. If you've met binary for the first time just now, then hi, welcome to binary. There's a function, so in normal numbers, multiplying by 16 and adding 5 is quite a hard function to describe in words because we don't really have nice words for multiples of 16. But in binary, this bit, multiply by 16, means, so what, 16x. That's terrible abusive notation. 16x means something like, 16 is 2, 4, 8, 16 means something like write 4 zeros on the end. Like in decimal, you write zeros on the end to multiply by 10. In binary, writing a 0 on the end multiplies things by 2. So I'm doing that 2, 4, 8, 16, 4 times. So I write 4 zeros on the end, and add 5 to a number ending in 0, 0, 0, 0 means change last digits. So you do adding by just adding the columns together. 5 in binary is 1, 4, no 0, no 2s and a 1 to 0, 1, 0, 1. Because it's adding on a 1 and adding on a 4. That's how you add 5. 4 plus 1 is 5. Welcome to the Oxford MAT Livestream. So overall, this function write 0, 1, 0, 1 on the end, which I think doesn't really work for the number. Yeah, works for almost all binary numbers. Yeah, good. Also request for an open day problem. That's from the April open day. Oh my goodness. Do hexadecimal. Hexadecimal is the same thing, but with 16 instead of 10. You can invent your own by changing the number 16 to your own favourite number. Hexadecimal has to invent some extra symbols because you run out of symbols after 9. Perhaps disappointingly, they went for A, B, C, D, E, A, B, C, D, E, F as their extra 6 symbols, which we were already using for words. Well, they could have maybe picked some emoji or something. I think it was before emoji. It's definitely before emoji. So that's how the numbers work in hexadecimal. Goodness me. Is the units column 2 to the 0? Yes, it is. The units column is 2 to the 0. Just like in decimal, the units column is 10 to the 0. We put binary in a math question a couple of years ago, and was it last year? A couple of years ago, and we explained binary in the question as well. And then binary was one way to do the question, but you could also do the question without using any binary after the very first bit of binary. We've had a request for question 10. Yeah. So they're calling them tens and hundreds. That's a great request to change the pen colour. This is horrible, isn't it? Yep. So overall, it was writing 0101. Sorry. Yeah, I don't know how I ended up. How did I get on that pen? Oh, I switched over here. That's bad. Sorry, I like using this one for circling ones. Anyway. Integer parts? Do you want to do integer parts? Oh yeah, the tens column is now the twos column. The hundreds column is the 2 squared, the fours column, because 100 is 10 squared, 4 is 2 squared. People still doing flags in chat. I think. Oh, is that crimson? Is crimson a sort of red? It's a new difficult question. There's something on one of them. We've talked about non-integer bases at some point. Don't want to do it now. When we did the binary question a couple of years ago on math, I found out the following day that lots of people don't like binary and don't consider it to be a sort of maths or a thing that they knew, which is a bit sad because I think it's cool. I found out that lots of people considered that to be not okay. Let's do another binary question. I just think it's nice. So this one measures the, this is like the length. This is something to do with the length in binary. Maybe a good way in is to say, I think it's a length. Goodness, let's try some numbers. So if I put in 2, let me just check. Maybe -1, because that will give 1, and I want the number -1 or something. It's something like that for the length in binary. Maybe this is not a fun way to introduce this floor function idea. That this floor function thing could maybe be. Maybe this question would be nicer if it was log base 10. And the decimal expansion. Would that make people happier? Always on that mission to get up from 3 stars to 4 stars. Yeah, so it was a past question too. So it's people on question 1 to 5. I'm not sure if I'm ever going to do a binary question again. Why is the floor of -e -3, not -2? Good question. It feels like maybe it feels like it should be -2 because the floor of e is 2. So the floor of -e should be -2, right? The floor function kind of breaks symmetry. It looks at the largest integer that's less than. So for example, -3 is less than -e, and -3 is the biggest integer that's still less than -e. Which is maybe a little bit weird, but you've got to do it a bit like that, I think. If you want to talk about larger than or smaller than, you kind of got to do it like that with negative numbers, I think. So -3 is the biggest number that's still smaller than -e. It's sort of like rounding down rather than rounding towards 0. And maybe rounding towards 0 would be a nicer thing. No idea what's going on, but thoroughly enjoying it. We're rounding down numbers. We're not largest. It's concepts. You have this in physics, right? Largest things. Yeah, good. Cool. Binary. And I'm regretting the binary, and I'm wishing that I put a 10 here. Look, I could have improved everyone's day if I put a 10 here, and I'd written decimal here. Expansion X. Yeah, but does the phrase decimal expansion mean anything? Maybe that would make people more cross. We'll never know. Okay. What's the floor function? Oh, that's the name for this. I don't expect people to know the phrase floor function. There's another one called the ceiling function. The ceiling function takes the smallest integer that's bigger. It rounds things up. This is a ceil, so below the line. Yeah. Other things that we throw into math questions quite a bit. So other things we throw in are sort of like this thing, which is... No, we did this in vectors, didn't we? I don't need to explain this. This is in vectors. This is x if x is positive, and it's equal to -x if x is negative or 0. Flashbacks to one of the MAT live streams. We're in a MAT live stream right now. You can't have a flashback to a thing that's currently happening. Ceiling, floor, chair. Yeah, so some people write the floor function like this. If they want to stress the kind of floor nature of it, probably because they're going to write this one for the ceiling, if you're in some sort of evil floor and ceiling kind of world. And some people use square brackets because it's easier to type them on a keyboard. So really, really lazy people might write square brackets in their worksheets like this. Good, okay. I love binary, I love chocolate and ketchup, but not together. I also love maths, but this is confusing since I'm in year 10. Thank you for the review. That sounds like it should be on the website, doesn't it? This is sometimes called the modulus function, yeah, sure. I'm not really sure how I feel about that. There's sort of absolute value. The problem with using names for things is that sometimes there's multiple names and you have to be able to spell. That's a disastrous attempt at spelling the word value. I'm having another shot at that. It's just gone 6 o'clock. Welcome to the live stream. We're about to finish the warm-up, more or less. A number of factors. There's this expression. I'll just leave that in the warm-up, I think. I think it's time to do some math questions. I think we'll do it. Good. Right. Ooh, could it have been a joke about rounding pi and e? Can I turn this into a joke? Okay, exercise for James. Pi e, some sort of a joke. Cool, homework from me. Okay, what next? No, we're not doing that. Right, okay, we're going to do some short questions. I've got a new one I'm very excited for. What are table and chair functions? Why is everyone talking about them in chat? We did spend an hour on that. It's the hydration check. Remember to drink water, everyone. The suggestion in chat, is it coming through now? Did it get through? Yeah. Drax, defining it as the square root of x squared. That's chaotic. Is maths at uni similar to the style of mat and step? Oh, and then there was a question that got flagged that's then disappeared. We're not doing the proof of the Taniyama chimeric conjecture. Stop requesting hard maths. Is maths at uni similar to the style of mat and step? Not extremely similar. I think mat and step are in some sense quite limited in what's going on. At university we teach a lot of theory, we teach a lot of new stuff, so you learn about different things. Mat is almost crazy in the way that it's about a very small number of things. We're trying to do hard things, we're trying to do tricky questions with them, but it's about a very small number of things, which is why sometimes the questions bring in binary or floor function or ceiling function or absolute value, because you can just about explain them inside the question and then do some more stuff there. But the maths on a very, very small limited set of things, and university it's more about learning about more stuff that's out there. Yeah, thank you. Who did the water reminder this time? It's very good. Good. We've got a new math question. I'm saying new, I mean it's from 2014, so it's not extremely new, but it wasn't on the MAT livestream last year, so I'm looking forward to this one. Let's switch on a poll for doing this question. Votes in the poll are hidden to start off with. If you're trying the question at home, or if you've already had a go at it because you got bored during the warm-up section, there we go. Here's a way to vote and show your opinion of what the answer to this question should be. Really excited about this. It's got a function, and we are asked to work out the value of f evaluated at the number 6,000. We could work them out one at a time. I'm really hoping that we spot some sort of a pattern. There's this thing going on here where either the value of f of n, it's sort of related to the value of f at the previous number. So this thing is maybe equal to f5999, but there's different cases, depending on whether 2 or 3, or both of them, or neither of them divides n. So, what's my favourite thing? No, don't get distracted. So we've got these kind of different cases. A good idea when you're presented with something like this is a sequence, by the way. It's been written down like a function, but you could write this down as like a1 equals 0, and then for all n bigger than or equal to 2, an is equal to blah blah blah, so on and so on and so on. So if you prefer sequences, which was episode 1, episode 0 of the series, then you can reinterpret this all as sequences if you want to. Good idea, sorry for interrupting myself. A good idea for sequences like this is to work out a few terms. And I think on this one, if you work out something like 10 or 12 terms, then the question falls apart and you are done. In particular, as we work our way up, so as I work out something like f of 2, which I should start doing. Oh, there's a hint at the bottom here to work out f of 2. Hint's not printed in the original math question. Okay, so f of 2, I need to think about, does 2 divide n? Yes. 3 does not divide n. That is true. 3 does not divide 2. But 2 does, so I need to add on 2. Okay, I had that on to f of 1. Okay, and now for f of 3, I think f of 3, right, so I need to think about n. 3 divides 3, that's true, but 2 does not divide n. So this is a case where I add on 3, so I get up to 5. And then for f of 4, I'm looking at f of 3 and adding on something. 2 divides n, but 3 does not divide n, so I add on 2. And that's f of 5. Neither 2 nor 3 divides that, so it stays the same. F of 6. So I keep going, right? 2 and 3 both divide it, so I add on 4, and I get 11. And I keep going, I guess. There's a question in this hint that I added on to say, when do you expect this to start to repeat? Because I really like this trick of working out a few numbers at the start to find a pattern. This is the sort of thing which you can do, hopefully, with just you're adding small numbers together, so hopefully not your entire brain. And part of your brain can be thinking ahead a little bit to, when do I expect this to repeat? What's happening as I go on? And already 6 feels quite special, because 6 is the first time that I've triggered this condition for 2 and 3 both dividing n. Actually, that's going to happen every time it's a multiple of 6. If 2 and 3 both divide n, that's the same thing as saying if 6 divides n. That's exactly the same thing, right? So that's going to happen every 6, and actually there's a pattern that repeats every 6. Let's think really carefully about f of 7 here as well. 7 is not a multiple of 2, and it's not a multiple of 3, so that's not okay. So now I've moved 6, and it repeats every 6. Drax says that it reminds them of Fizzbuzz. So, yep. And Cal Frederick asks, as invented, God, I love this, is the phrase hexachotomy for the 6 possible cases. Someone says the teacher's forbidden hole punching, which is a bit sad for organisation. Okay, we're going to have a quick look at the poll, but first I want to look at chat a bit. Do I want to look at chat? Yeah, let's have a quick look at chat. So I'm going to switch off the poll for a minute. The poll's doing quite well. We've got 28 votes. People are voting at the moment for what they think's happening. Possibly this thing repeats every 6 because the cases that we trigger as we go through, working out f of 8, will trigger some sort of similar stuff compared to the way we trigger f of 2. And then I think we're going to go around 1,000 times to get around to f of 6,000. Being a little bit cautious, because if I go all the way around 1,000 times, I'll get to f of 6,001. Oh, I'm really scared about that, but it's okay because the 6n plus 1 case is the same as the 6n case. F of 6,000 was the same thing, because this one is equal to f of 6,000. Okay, right, so we'll go around 1,000 times, and I added 11 the first time round, so I think I'm going to add 11 1,000 times. And chat at the moment agrees, 86%, that's pretty good chat. Some votes for B. How do you get to B? Don't know how you get to B. And some votes for actually almost everything else. Okay, cool. Questions on the PDF version are different. Thank you. If you've downloaded the PDF version of this, then you might be doing some sort of different question from last year, because I tried to update it, but maybe it didn't hit every version. Thanks, Garfield. There's only 5 options. Is it a pentacotomy? Well, there's kind of only 4 options, so is it a quadracotomy? I think we're inventing words. Good. Someone wants to see the tip of the tablet pen. I don't know why. I looked at it the other day. I think I've worn it down over the last 2 years of doing these. I don't know, maybe you can change them and replace them over time. Is it true? Somebody asked, is it true that if you do BMO2 you get an automatic interview? And I think the answer is no, because we have no way to confirm whether or not people did BMO2. So please do the math. Good, right, okay. That was question 1H. Good, okay. When did we start adding option E? I think it was 2014. Interviews were in second week of December. Okay, this question was here last year. And the hint is kind of similar. Try some small numbers. It describes a process. I quite like the idea that you open your maths submissions test in 2015, you turn to the first question, it's question 1A, you're ready to do the test, and it says pick a whole number. Okay, that's an instruction we can do, right? Pick a whole number. It feels like a magic trick. Add 1, square the answer, regret. Multiply the answer by 4, and subtract 3. Oops. Which of the following statements is true regardless of which starting number was chosen? I see, so felt like I had agency about picking the number, but now I see that it's supposed to be true regardless of which starting number is chosen. So you decide, how does this magic trick end? Oh, what was the answer? It was C. C. 1,000 times 11, 1,000 times 6, 1,000 times around the merry-go-round. Okay. We've got to choose. So this magic trick is going to have multiple conclusions. So it's slightly odd. There are some Roman numerals here for different punchlines to the magic trick, and then we're going to select that some of them are true. Good. Oh, poll. Poll. Everyone loves a poll. Good. Right. The thing about the poll is we can't see chat. Good. Okay. Ooh, different approach in chat for the previous question while you're thinking about this one. 2,000 numbers that are a multiple of 2 and not a multiple of 3, and 1,000 multiples of 3 that aren't a multiple of 2, and 1,000 multiples of 6. That's a really good way of approaching it. That's probably better than my pattern extending method. Because, yeah, that's really nice. Yeah, think about how many times each case happens on the way up. Because this thing's just adding, so you're just making a really big sum. I saw, I think Raphael's posted the differences in the terms, which is a trick that I've seen for identifying quadratic sequences or something, to think about the differences in the terms, and there was a nice pattern for those, because of course there was nice patterns everywhere for this. Did not understand the 14 question 1H, the previous thing. There was a nice pattern going on. I didn't write down very much pattern. People want to try small numbers. Pattern's a bit more tedious, I suppose. I suppose this is just a quadratic sequence. Now that I've said quadratic sequences are not explicitly, well, they're not at all on the math syllabus. So maybe I should stop saying quadratic sequence. Let's try some small numbers. So 37 was too big, too ambitious. Multiply the answer by 4. I can do that. Subtract 3. I've got 13, which is odd. It is a multiple of 3. It is 1 more than a multiple of 8. That's not true. And it is not prime. That's false. And it is not 1 less than a multiple of 3. That's true. Okay. So it's looking like maybe 1, 2, and 5 could be true, but the answer could be E. Could be C. If I try 2, is it always odd? It is always odd, isn't it? It does look odd because it's 4 times something. 4 times something feels pretty even. This last step, this gives you an even number, and now it's odd. So the final answer is always odd. So I'm not up for option C. Not up for that, because that one doesn't include the correct information that option I is actually always true. But let's stop thinking about whether things are odd or even. Well, maybe not, who knows. Pick a whole number, add 1, square the answer, multiply by 4, multiplication live on stream, subtract 3 at 33. That's an odd number, because of course it is. It is not 1 more than a multiple of 3. It is 1 more than a multiple of 8, but I'm not really interested in that anymore. It is not prime, and it is not 1 less than I'm so confused. Is not 1 less. No, it is not 1 less than a multiple of 3. It's a multiple of 3. My goodness, 5 not 1 less than a multiple of 3. It's true, because it's 33, which is a multiple of 3. which is not 1 less than a multiple of 3. Oh, goodness me. My chat is completely playing up, but it's sort of behind the scenes, so it's all right. Why is it 1 more than a multiple of 3? I don't think it always is 1 more than a multiple of 3. I think 13 is, but then 33 isn't. So I'm not sure I feel very confident about this. I think so far, so we found an example where 2 is not true. Option II is not true. It's not always 1 more than a multiple of 3 because 33 is not 1 more than a multiple of 3. Should I get 33 correctly? Good, yep. Not interested in 2, which means not A. Not 3. Oh yeah, 3 was not true as well, ages ago. And 4 was not true. I think it's looking like E, isn't it? Is it looking like E? Chat, help me out. We've got some votes in chat. Chat, help me out. Yeah, chat's with me. Chat's on E. Now I understand this. I think some votes for A. People who believe 2 is true, so I should have maybe another look at 2. So yeah, 8% of people believe A is true, and some votes for B as well. I don't really believe that 4 doesn't feel very true to me. Maybe it does feel a bit true. No, because when n is 1 I get a prime number, so not interested in B. Am I interested in D? I'm a little bit interested in D, I suppose. Got to think about... E is 1 more than multiple of 3. No, it's just not true. When n equals 1, it's just not true. It's not true when n is 2. Good, right, okay. Small numbers for the win. Good stuff. I'm not sure I know a better way of doing that. There's a question, I think. Here's a question. Can you prove it algebraically with 5 upvotes? Thank you. Let's go. Let's try and prove some of these. So, algebra, for people who don't like trying small numbers, which I think, to be honest, is how I would like to approach this question. Because if it was me doing the math, which I don't have to do, but if it was me doing the math, then I think I'd probably try and write down some algebra for this. Square the number, multiply the answer by 4, subtract 3. Right, okay. So straight away this is odd because it's equal to 2 times 2n plus 1 squared minus 2 plus 1. So it's odd, so that's true. So that's proof that that's odd. Is it 1 more than a multiple of 3? I think we've actually decided this one's not true by counter-example. Let's try and prove, so let's think about options 2 and 5. Let's think about multiples of 3. Somebody asked ages ago, what's an example of why you would care about writing n as different cases with 3's in, and here's an example. Here are 3 possibilities, the trichotomy. One of these. If n is 3m, then I can plug it in and I'll get 2 times, oh my goodness, this is going to be a bit of a mess, isn't it? No, let's not plug it in there, let's plug it in over here. I'm also going to plug in 3m minus 1 instead, which is fine. It's one of the things that I would have got away with it if it had been the first thing I wrote down, but because it's not the first thing I wrote down. That is 1 more than a multiple of 3. I hope Chris has got back with the results of multiplying cases together, because that's basically what I'm doing here. This is 4, 16, take away 3 is 13. This is also 1 more than a multiple of 3. I'm not bothering, so I could bring out the factor of 3. I'm trying to spare you the algebraic detail, but I could write down equals 3, big square bracket, and then if I try really hard, I can write down something in here. And this one I can write down 3, big square bracket plus 1. But I'm trying to spare you from actually writing all that out because I don't want to multiply out the square. So I'm just telling you what happens. Minus 3 is a multiple of 3. Okay. If making a substitution, would you consider doing the algebra first, then making the substitution at the end to avoid mistakes? That's a sort of good question about sort of the theory of mind of how you get towards answers. I think I'm sort of doing both. So I wrote down 3n plus 2, but I was already thinking about what would happen when I started subbing it in to actually do the algebra to plug it in. And I realised I wanted a -1 instead, which is sort of equivalent up here. Equivalent at the bottom down here for what these cases are, but makes the actual working out nicer. I can sort of start seeing in my head that this was going to happen. I don't know. You can just sub in 0, 1 and 2. Yeah. 0, 1 and 2. Plugging in 0, 1 and 2 is enough. What we're kind of doing by thinking about the trichotomy at the bottom is that plugging in 0, 1 and 2 is enough, that you're then done. No comment on the answer not being prime. I mean, other than by counterexample n. Counterexample n equals 2 is probably the best way to do that. So maybe I do have to try small numbers. And 3 is just false, so counterexample error as well, I guess. Okay. Right, proving things as false is sometimes a bit disappointing because they're false, so just one counterexample is enough. Yeah, this thing at the end, this thing about squaring things and thinking about the remainders is something called, so you don't need to know this to do the question, but squares and remainders have an interesting interaction. If you haven't thought about them before, you should think about square numbers. What are their remainders when you divide by 8 or 6 or 3 or 41 or something? There's something going on. I mean, there's not nothing going on. There's a small thing going on. And then, after you've thought about it, so what's the remainder when you divide square numbers by 3 or by 6 or by 8, the thing to look up is called quadratic residues, which quadratic sort of means square, residue sort of means remainder, so you can sort of see how that name came about. Not a great name. We've got a couple of long questions to do. Yeah, mod 3, if you know about modular arithmetic, then that's part of what's going on there. We are going to, it is also in, before we do the long questions, it's also in Oxford Online Math Club. For reasons that I don't really remember, it's in the very first ever episode, which is just me trying to explain quadratic residues with basically no experience of doing live streams, so it's not very good. Well, compared to now, when we got this, it's going extremely well. We're going to talk about Fairmont's List theorem? I don't think we're going to have time, but we're going to try and do this long question quickly. Oh, it's 6:20. We're doing okay. I don't love, so hang on, let's do the modular arithmetic chat. I feel like I don't love the 12-hour clock analogy, because the 12-hour clock, people have got quite strong opinions about how 12-hour clocks work, and some of their opinions about how you tell the time don't translate into modular arithmetic facts nicely. 12-hour clock has only got the 12 numbers written on it. So then people feel a bit iffy about, are those the special 12 numbers? But that's not quite how modular arithmetic works. Did we already do this question? Hey, did we already do this question? That is a good question. If we've already done it, we should not do this. Request for a Twitch channel. Noah, you do not need to know about power series for math. Power series is a big topic. We would have to put it on the specification if we wanted to know about power series. You know about geometric series, which is a closely related sort of thing, but smaller. Yeah, good. Okay. Should we do this question? We did. We did the previous one. Which one? That's very confusing. Do it again? I sometimes feel like I'm repeating myself, but apparently I'm repeating myself quite quickly. That's really concerning. It means that there's a repeat. Did I get the answer right both times? When did we previously hit this one up? It's algebra? Like recently, right? Recently? Or like, not recently. I'm so confused. Just checking before I spend all of this time doing it again. Do we do it on, yeah, I feel like I've done this question a lot of times in my life. We're going to do it again. Okay. Sort of Groundhog Day, because I feel like I might be going around in circles. Ooh. Have I done this at a different event or something? let's just go for it. Let's just go for it. We're going to do this question. I don't know if people have seen it before, but it's on the worksheet, so we're gonna have a go at it, and then we're going to move on to a different long question. I'm going to try and do 20 minutes on each. Let's go. So, first part is to expand and simplify. It's worth working systematically. I go first bit of this bracket multiplied by everything, and then maybe even on a separate line, I would write out negative b multiplied by everything. I'm going to use their dots as well. You've given me dots, I'm going to use dots. Minus a to the n b. I like writing the letters in alphabetical order. Minus 2b cubed minus dot 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 minus b to the n plus 1 for subtracting all of these things. And then brilliant observation, I've messed up my b's, haven't I? So it doesn't quite work. Brilliant observation is that most of this cancels to just give a to the n plus 1 minus b to the n plus 1. Good, right, fantastic fact. Simplifies really nicely, loads of cancellation. This bit here cancels this bit, and then that bit cancels that bit, and on and on and on. So this is equal to a to the n plus 1 minus b to the n plus 1, which is brilliant. It tells you how to factorise this difference of two powers. It's like difference of two squares, but bigger, better. It tells you how to do the difference of two cubes, or the difference of two fourth powers, but you already know about the difference between two fourth powers, because that's another example of the difference of two squares. It cancels out so much, it's so good. We've got a mark, or maybe even 2, for doing the simplification, who knows. This part is one of the warm-up questions, right? This is n squared minus 1. Maybe this is what people mean by repeating this. Is this what people mean? Good, that's a repeat. And then this is part to find all the prime numbers that are one more than a cube number. So for part 3, it's this idea that it would be nice, can we factorise n cubed plus 1? That's maybe not something we've considered doing before in A-level or something. It's related to the things going on in this question. You get a chance to be a little bit clever in your use of how you use the things in this question. We've seen a way to factorise a to the power of n minus 1 minus b to the power of n minus 1. And we're now faced with the challenge of factorising n cubed plus 1. But there's a thing we can do. Yeah, cool. I don't know if the pen striking the tablet has got louder over time, as I get. It's something people complained about way back in the first episode as well. Oh no, it's before I had a tablet. I really don't watch the first 2 episodes before I knew what I was doing and before I had a tablet, so everything was bad. People are saying that n minus 1 is a factor. Maybe that's for part 2. It's not for part 3, right? n minus 1 is not a factor of this one. Is it? I think it's not. Because 1 is not a root of this polynomial. It's got a plus sign in. A fiendish plus sign. There's a suggestion in chat of how to factorise this. Oh, sorry, Denim. I think I might have misread. Yeah, Denim's edited it to a plus sign in chat, so n plus 1 and then work it out. And an anonymous person has factorised it out properly. Denim's fixed it. So I'm kind of interested in how you got there. So ways you might spot this, you might think of this as a polynomial, and to think about its roots, and to think that it's got a root of minus 1. So it's got a factor, you know, like with the factor theorem, it's got a factor of x plus 1, so you can go and factorise it like a polynomial. There's a way to use the first part, which nobody has said in chat. Does anyone want to do that? This is an example of the thing in the first part with a to the n plus 1 minus b to the n plus 1. This factorisation that's going on. Yes. Oh, yeah, there we go. Thank you. An anonymous person has got in there first. Getting all of the kudos for being the first person to tell me how to use part 1, but anonymously. Yeah, cool. So you can use this with b equals minus 1 and n equals. Oh, I didn't really. N was maybe a bad choice, wasn't it? We already had an n in this question. I'm going to change that to an m. N is equal to 2 or something. Brilliant. And then in part 1. If you put that in here, you get the difference between cubes, but this thing over here, it's the difference between cubes because it's the difference between difference between m cubed and minus 1 cubed. Brilliant. Chat's coming in as well. Different amounts of chat lag for different people. Yep, maybe people have been thrown off by the fact that I was using n for everything as well. Good, right, good. Okay, so I think that means it factorises really nicely. Either way, whether you're thinking about it as a polynomial or not a polynomial, you get these nice alternating plus and minus signs. Homework, if you like, putting in even numbers for n and -1 for b is really nice. Just works out nicely. -1 for b. You get the nice minus plus signs. Can't explain why I like it, I suppose. I check if either is 1. And checking if it's 1 means checking, oh, maybe m is 0, or maybe m is 0, or maybe m is 1. Is the other root of that polynomial? Is it? No. Yes. check 1 as well. If you check 1, then you end up with a prime number 2. So 2 is a prime number that is 1 more than a cube number. And also 1 is more than 0, but 1's not a prime number. So I think we're good. Good. Just before we went live today, I got permission to not say bracketifying anymore. I'm just saying factoring again. How does using 1 help? Well, it stops me from thinking when I need to factorise m cubed plus 1. Thinking is hard, and chat seemed quite keen to go and factorise it and just get on with it. But part 1 tells me how to do that without thinking too hard. Okay, part 4 has got a trap in it. I can't endorse any particular supermarkets because that would count as an Oxford endorsement. Lots of supermarkets are available. Why isn't 1 a prime number? And that's got 1 thumbs up, which is the correct number. Because 1. It would mess up something that I like about primes, which is unique factorisation. It's the sort of shortest possible answer, I think, that if 1 counted as a prime, then you wouldn't have unique factorisation, because you would factorise things like 15 as 3 times 5 times 1 times 1 times 1, which is the same thing as 3 times 5 times 1 times 1, which would be a bit disappointing. You'd have to say that factorisation is unique up to order and the number of 1s you have around, which is a bit messy. If A is 3 and B is 2, what have I done? If A is 3 and B is 2, yes, right, people are doing the next part of the question. Sorry, I have to remember, if I'm on a tangent, other people are getting on with it. Let's clear some space. So there's a trap to try and work out the previous thing, but with A is 3 and B is 2, because that looks like the difference of 2 powers. So there's this sort of trap in part 4 to write down that it's 3 minus 1 times 3 to the 2014 plus 3 to the 2013, 2 to the, goodness me, 2 to the 1, and so on, with like n equals 2014. 3 minus 2. Poor explanation of a poor strategy. So yeah, okay. So this is true. It gives you a factorization. Unfortunately, this first bracket is the number 1, and even primes. All primes are allowed to have the number 1 as one of their factors, so we need a different idea. The hint I suppose I would give someone who is stuck on this question is if it is prime, it's going to be almost impossible for us to do this question. Proving that a big number is prime, this is a big number, proving it's a big number is prime is really, really hard. So let's hope it's not prime. Let's put all our effort into trying to prove that it's not prime. Yeah, some suggestions as well for other ways we can use question 1 to be a bit more clever. Let's read some of these. Rewrite it as that. Using square roots of 3 isn't easily factorisable to 1, so mustn't be prime. I'm not super excited about the square roots of 3's, because the square roots of 3's don't, your brackets don't look like whole numbers to me, because square root of 3 is not a whole number. I suppose there's something going on where if we stick to using whole numbers, then we're definitely writing down whole number factors. So we might write down a whole number factor that's definitely a whole number factor. There's some suggestions underneath as well to factor 2015 out, to use something like this as the fact that what we're being asked about is actually this number. Maybe this is a bit cheesy, or it's sort of this number, and then to use n equals 402. Oh yeah, or to think about it as 3 to the 403 to the power of 5 minus 2 to the 403 to the power of 5, and to use n equals 4. That's probably nicer, I suppose, because then you get a bracket out the front that is not 1, it's some non-trivial factor of this number. That's really what we're doing, by the way. We're taking something that's the difference of 2 powers, and we're writing down a non-trivial factor if we can, by saying, aha, it's got a factor of a minus b. Yeah, so people in chat using 3 to the 5s, 2 to the 5s, yeah, cool, okay, good. Oh, n equals 1007, a equals 9. Oh, that sounds too clever for me. That sounds really clever. Oh, squaring. Isn't that going to tell you about 1008? I think it's going to tell you about 3002 to the third. There's anonymous 1007, a equals 9. I think it's going to tell you about 3 squared to the power of 1008, which is 2016 minus 2 squared. I like what you're doing. You're bringing it inside, but because it's n plus 1 on the right hand side, I think you're telling me about things 2016 instead of 2015, which is like next year's version of the question. Non-trivial is a word. Sometimes people say trivial factors for the obvious ones, the trivially obvious factors like 1 itself. And sometimes people say non-trivial to mean not those ones. And then you could say primes numbers that don't have any non-trivial factors. I saw someone say that primes have exactly 2 factors, which is one way of working with it. That doesn't generalise very nicely to negative numbers and complex numbers. And a reasonable thing for you to say next would be, I don't care about negative primes and complex number primes, and that's fine. But somehow the phrase no non-trivial factors generalises quite nicely, because you can just tweak what you mean by trivial, and you can say no non-trivial means, aha, I just need to change my little box of trivial factors, things that are obviously factors in my different system. It doesn't have to be. I've mentioned complex prime numbers too many times. What are we doing? Oh, this question's got a rider on the end, an extra bit of question on the end. Which has nothing to do with the other stuff as far as I can tell. Happy to be corrected. But I think this just looks like a cube number, right? It's got 2's instead of 3's. Maybe this is a cube number. This is a cube number. Oh, it's k cubed. This is k plus 1 cubed. This is in between. Right, okay, sorry. Check that it's actually in between, because 2 is in between 1 and 3, but think carefully about k. Okay. This last part's completely unrelated. I would be very interested in anybody can come up with a way to the Gaussian primes. Anybody can find a way to use part 1. I'm not sure I know a way to use part 1. I'm going to quickly check the MAT website to see if the solution from 2015, before my time, see if the solution from 2015 had a clever technique in. I should log out of this website more often. Solutions 2015. So I'm on the MAT website, which you can find for grabbing the kind of we put one version of a work solution up each time. What question number was this? Was it 2? Yep. No. Nothing using the 1. Oh no, hang on. Yeah, there's a different method in there. There's a different method on the website, which you might be interested in. It looks like this. Which, you know, alternative approach. And this is one example of how sometimes there's more than one way to do a math question. This looks a bit like a mess. Right, good, okay. Okay, it's between some of these. Part 4. So this is not a prime number. No. No, it's a multiple of 3 to the 5 minus 2 to the 5. The best way to write down that something is not a prime number is to write down one of its factors. Here, you can just write down one of its factors. The clever bit of the question is to think of how did I notice that it was a multiple of 3 to the 5 minus 2 to the 5, and that's by cunningly using part 1 with particular values of a and b. Our first guess of putting in a equals 3 and b equals 2 gave us a true fact, but not a helpful fact. It gave us a true fact that told us that the number was a multiple of 1, which is not interesting. But if we put in slightly different values, we could prove that it's a multiple of 3 to the 5 minus 2 to the 5. Or people had other suggestions in chat. The Prime Minister is here, says Kai in chat. Good, okay. What are we doing? We're doing one more question. 20 minutes? Do we hit 20 minutes? We hit about 15. That was quite good. Let's see if we can hit another 15-minute question. Oh, it's this one. Digit sums. So this is a math question where it defines something at the top. This time it's digit sum. It's also said non-negative integer to stop people worrying about negative numbers or complex numbers or anything like that. Bad luck, everyone. The digit sum of 123. They've given us an example that 1 plus 2 plus 3 is 6. Welcome to question 5 on MAT 2013. Would I say that 3 to 5 minus 2 to 5 does not equal 1? Or 3 to the 2050 minus 2? I suppose so, yeah. I suppose for an extra, if I had a spare 20 seconds, I would write down 3 to the 5 minus 2 to the 5 is obviously not 1, and it's obviously not as big as 3 to the 2015 minus 2 to the 2015. So it's a non-trivial factor. Ooh, horrible approach. Always up for a horrible approach. It's k plus 1 times... Oh, that looks nice. Oh, it is. It's k squared plus... Oh, you factorised it. That's not horrible. Factorising is good. K plus 1 times k squared plus k plus 1, which is only a cube. So you find a k plus 1. So that other bracket has to be related to the k plus 1. Do I believe that? I'll say that's dodgy, but I'll keep reading. Get a quadratic data discriminant and find the solutions. Okay, sounds fun. Do I believe that one of them is c cubed times the other, where c is an integer? Do I believe that fact about cube numbers? I think it has to be rational. I'm not sure it has to be a whole number. Anonymous, I like it. I'm a bit worried about whether c is a whole number or if it's not a whole number. But you've thought about this more than me, so maybe it is a whole number. In which case, cool. And I don't want to see the quadratic discriminant stuff, I trust you. We're allowed to make ironic comments. I'm never really sure what the line is on chat moderation. Which is weird, because I do a lot of chat moderation. Okay, right, we're talking about digit sums. Yeah. Okay. Ooh, squared. Yeah, no, that's part of your quadratic. I believe you, Anonymous. Okay. Euler here as well is on my thing as well. I've realised people are asking me about the graphics tablet because of graphic tablet stuff. We will work something out. I'm not supposed to give too many details, but we can work something out for interviews. In previous years, we've worked out stuff for what to do if somebody doesn't have a tablet, and we've got options that, yes. Okay, I don't want to go into too much detail. Short answer, no. It'd be nice if you've got access to one through school or elsewhere, then that'd be nice. If not, don't worry. No comment. Right, good, okay. Yeah, good. That is precisely the question that I've been told not to answer. What a great time. Big Dog's got a question. How come you guys don't put the marks per part one question on the actual paper? We're trying to simulate something in the real world where you don't know how hard questions are when you see them. So you see some questions, and if I revealed, for example, that one of these parts of the question is much easier than the other, then you might skip down to it just to do the easy part of the question, which wouldn't be very realistic compared to solving problems in the real world. It's just slightly different to not to get any information out of it. If we put all the marks down, people would have a bit of a game, people would try to get an edge by inferring stuff from the number of marks. True or false questions would sometimes. But yeah, we're on the proof episode. I can do this. Imagine I want to ask a question where I say either find an example or prove this is true, or find that counterexample. So either find a counterexample or prove that it's true. Complicated fact, prove that it's true or find a counterexample. It's about prime numbers or something. So this is always prime. Prove it's true or find a counterexample. Brackets, 1 mark, close brackets. That would make you suspicious because you would try proving it a bit and you would think, if this proof exists, it's very complicated. There's only 1 mark for the question. Maybe I should look for a counterexample instead. And it would nudge you in that direction. I don't like that as a way to get information about the question, that you see 1 mark and that says, oh, counterexample, not a proof. So hiding the fact that it's worth 1 mark gives you a slightly more realistic impression. Oh, good. Thanks for asking for that during the proof and counterexample question, because that's kind of, I think, the main reason. Oh no, okay. Can we use a calculator in the interview? Probably not. Probably not going to get a chance, and I can't imagine asking a question in an interview where a calculator is very helpful. Disadvantage for not having a graphics tablet? No. You see, I tried to answer really carefully so that you would. Okay. You're not going to be disadvantaged. It's going to be fine. We will work it out. I think you should apply. Okay, right, good. What are we doing? Pat has marked. Oh, physics correspondent here has told us that the physics test has got marks, and they find this stressful. Sometimes not knowing. Good. Okay. We are looking at the first part, which is positive integers less than 100 with digit sum equals to 8. So we're looking for the ones where the digit sum, the numbers that add up to 8. I suppose it could have 1 digit. It could be the number 8. That's the first one I thought of. Or it could have 2 digits. It could be the number 17 or 26. Or let's think carefully. This is a little bit like when you're doing what's that puzzle called where you have to put in the numbers and you're given the totals at the edges? I think it's maybe a kakuru. You need to write down all the possibilities of things that add up to 8. I think I found them. How many are there? 1, 2, 3, 4, 5, 6, 7. I think 8. That'd be nice, wouldn't it? Is it actually 8? Oh, I've missed 80. 9. I don't have zeros in kakurus, so not getting there. Can we write it as 08? I don't think it matters, so I think we're good. Back to the studio. Thanks everyone in chat. Drax and Mames got in there. I think you can write 8 as 08. I don't think anything bad happens because it doesn't change the digit sum and it doesn't change what number you're talking about. So I think you're fine. If you want to call that 08, then you're good. The next part of the question is about positive integers less than 100 have digit sum equal to n. So just sort of generalise this. I think it's n plus 1. I think there's on essentially no evidence other than 9 is 1 more than 8. And now I'm going to try and prove why. So there's a 1-digit number with digit sum n. I can tell because they've made sure that n is positive and it's less than 10. So there's a 1-digit number, that works. And then the 2-digit numbers are going to be something like, it's not really a nice way to write down the digits of the number. So I'm just going to try and draw it. 1, n minus 1, brackets. There's just not a notation for it, right? For what the... Let me know in chat, what should the notation be here for when I'm trying to tell you the 2 digits of this number are these things? I've put round brackets around them. I don't love it because that's also how I write down multiplication. Yeah, increase and decrease. There are n of these ones and there are 1 of these ones, so total n plus 1. Okay, same pattern. Same pattern. Patterns. Increase the second digit and decrease the first digit. Yes, it's a good way to describe the pattern, thank you. You can have extra large paper even in international testing centres. I know the answer to that one, even though you've asked Prisma. Good. Can you conjecture n plus 1 and then not prove it? I don't know. I wish that this question said justify your answer a lot. I'm going to add that in. If I was in charge of this question. Hey, updating it to... Okay, I'm making the question harder, chat. Wow, am I making it harder or am I just making sure that people don't cheat at it? How do I move things? That's not how you move things. Making the question harder, but also making my life harder by trying to interact with. Yeah, this is definitely worth it. This is worth everyone's time. And good, right, cool. Right, we made it a little bit more me. Ooh, vertical bars, I like that. Concatenate. As a computer scientist. No offense if you're not a computer scientist, but that's a very computer scientist kind of thing to say, isn't it? Bar on top for a digital representation. I kind of need to write down these two things separately. This is my challenge. I need to write down 2 n minus 2, and I don't mean 2n minus 2. I mean 20 n minus 2. That's not. I could write down the number 20. I could write down 20 plus. Chat, we might be getting there. We might be getting somewhere. Right. Okay. Are we going to be caught out by at least 1 at the end of this? We've got about 8 minutes. There's something going on in here. Up to 1000, there is a nice pattern going on. Work really systematically. Rabil said earlier, changing the digits 1 at a time seems good. You could try and list them in order from the small numbers to the big numbers. I think you find that it's probably some sort of quadratic thing, something to do with n squared. This next part 4, wants to look at the ones between 500 and 900. It's maybe easier at this stage to think about what the possibilities for the first digit are, to think about the possibilities there for the first digit being 5, 6, 7, or 8. Can't be 9 because that would already be too much digit sum. And then to think about what the possibilities are for the rest of the digits. That in this case, if it's if we're just looking for a digit sum of 8, then there's not very much we can do. So kind of listing them all out is not that hard. And actually, you've already worked systematically like this in order to do part 3. This kind of triangular shape. That's why I said n squared, because of this sort of triangle shape of what's going on. Means that, okay, this just wants some of the triangle, so I think it's not too bad. Yes, Kai's got it. Yes, the 10s. I should write down the 10s, and then we're good. Anonymous person got there. What are the bars in the thumbnail? Yeah, the thumbnail. The bar is a different symbol for dividing, which I'll put in the thumbnail to save space. But don't expect people to have seen it before. That's an example of clickbait that's not very good clickbait, because it's showing people an unfamiliar thing. People click on unfamiliar things? Maybe they do. 1 digit at least. This phrase catches everyone out, I think. 1 digit at least 5. Not 5 digits at least 1. One of the digits is at least 5. So it's sort of like taking these ones and permuting the digits, I think. So take the ones from 4 and shuffle the digits. Probably that. Something like that, isn't it? Yeah, take the ones from before and shuffle the digits. How much detail do we need in proof for maths? If it helps, try to imagine that you're explaining explaining your maths to me or to whoever's marking it, which is usually a graduate student. But it should be enough to convince the graduate student that you know what you're doing, that you're not bluffing your way towards the answer. It'll probably, if you write basically anything, it's kind of usually a bit obvious that you're not bluffing. And that's all that I'm really trying to achieve by writing justify your answer on the end, to stop people going, oh, it feels a bit like n plus 1, so I'll just write down n plus 1 without really thinking or engaging brain, which is a bit like bluffing. To force people to actually go and write down something, you probably have to write down something true as well. But if you're approaching this honestly, and you're not trying to bluff or write down and make it look like you know what's going on when you don't, if you're approaching it honestly, then you should not worry about how much detail to put into proofs, because that instruction is just to catch out people who don't know the answer. So if you know the answer, you should be fine. If you have no extracurricular, that is fine with me. Yeah, Oxford's policy is very clear. Oxford's policy is we do not consider unrelated extracurricular activities when considering applications. Would Cantor disagree? I don't know Cantor's opinions on things. Wait, hang on. This is a joke about rotating numbers. At A level, it's said to explain it like it's as if to an idiot with a very specific vocabulary. Did you say that before or after I said to imagine saying it to me? So yeah, an idiot with a very specific vocabulary. The last part is an arithmetic progression. It's a really nice arithmetic progression. If you haven't seen this before, you should have a go. It sort of lives completely independently from the previous parts of the question. They're all about counting. This is about the total. The total is really nice because you can say big things about the total from 0 to 999. So this is pretty good. If it didn't say justify your answer, yeah. So did people just write down 9, n plus 1, something with n squared in it, 10, 20 something, 45 squared or something, and then call it a day? Did they get 15 marks? I don't know. I like writing justify your answer because reminds people to show they're working out as well. Does rowing help in a personal statement for Oxford? If you're applying for a course where rowing is relevant, then it would be a relevant thing, but if rowing is not relevant, and I think rowing is not relevant to any of the courses at Oxford, then yeah, I think rowing would be an example of that very specific policy we've got, that Oxford doesn't consider extracurricular activities when making academic decisions. Let's see if I can find that on the website. Somebody replied, yeah. Prisma's put nope unless you can make it about your degree somehow, which is not supposed to be interpreted as a challenge. One of the digits is at least 5, yeah, so there's last part, part 5. One of the digits is at least 5, or at least one of the digits is a 5. It means that one of the digits is at least 5. The other digits might also be at least 5, or they might be smaller than 5. In fact, because the digit sum is 8, I can tell that they're not that big. But it means one of the digits, it should maybe use more words. The space, there's so much space. One of the digits is at least 5, would be how I would put that in. Oh, have you asked about the organs? Yeah, so there's an exception, I suppose, that there's currently an organ scholar process where the organ scholars apply. They're considered on their organ playing skills, but they also need to get through maths interviews, and they need to then put in a normal application, and they need to sit the MAT. That's for the mathematicians anyway. As I suppose an example of an extracurricular activity that Oxford looks at, but only in the case of organ scholars. Yeah, so everyone's really seems like interpreting 5 in terms of just what does that bit mean, which is, I don't know. I think this question is quite accessible because it's just about adding together small numbers and counting carefully, and then it's got a nice arithmetic progression in, it's got a nice quadratic sequence hiding in there. But then the wording, I think we didn't quite nail it down perfectly on this one in terms of you have to interpret that part 5 very precisely. Maybe that's good. Maybe interpreting things precisely is something great. Garfield didn't put their piano grades on. Garfield, great news. Piano playing is also not relevant to the maths degree, so we don't need your piano grades. Should be fine. Prisma's off. Right, bye. Oh yeah, we're about to hit 7 o'clock. It's happening. The extension material this week that we're not going to talk about has got a proof in it, if you're interested in that sort of thing, that there are infinitely many prime numbers. It's also got a proof that there are infinitely many prime numbers, each of which are 3 more than a multiple of 4. So if you're interested in multiples and remainders and prime numbers, here's a nice proof that you get infinitely many of that sort. It might still be possible that there's only finitely many of the other sort, but in fact there are infinitely many. The proof doesn't work this proof doesn't quite work if you flip it around. So this is kind of exercise. If you've got some spare time and you want to think about proofs and breaking proofs, we had an example earlier on, way back over here, to try messing around to break a proof to see what breaks. Where was that? That was the early on warm up. Come on, here we are. Question 4.5. When is the nth root of 4 irrational? Just think about changing the 2's to 4's to see what breaks. Over here there's another example of, I've presented a proof in the extension, and so that if you change the 3's to 1's, something breaks. And it's worth playing around with that to find out what's going on. What if I'm worried that my maths supercurricular is not that interesting to me? It doesn't have to be interesting to me, it has to be interesting to you. It's you doing it. I don't have to do your maths supercurriculars. It's absolutely fine if I'm not personally interested. Prisma's off. Prisma put an announcement on there, leaving at 7 on the dot. Sorry if Prisma didn't answer your question. Thank you, Prisma. You've gone. Okay. Right, cool. There's a joke which has survived for this year, and somebody said they liked it, so that joke will now be there forever. I think I'm also going to run off. Have I missed any really important questions? Let's have a quick look at top chat. Top chat's usually good. It's the unofficial MAT countdown reminder. There's the reminder to Chris not to learn about everybody else. Yep. Maths. Yeah, no, there's the scooter did get bored. Lovely chocolate and ketchup thing. Not getting silly. Mame's generating 6 thumbs ups for being here. Good day. That's before you made your mistake about flags, which I still remember. Oh, I missed this joke about the year appearing in the question paper. Piano grades show you can count to... Yeah, okay, I suppose they're counting, right. Good. Switch some content, it immediately gets distracted by chat. I don't even know, that happens so many times. Have I missed anything? Verb missed an entire season by a rare moment where I was doing some maths. These long questions were okay, weren't they? I'm really worried that I've talked about 2015 question 2 like last week or the week before or something, and because when it came up, people said they'd seen it recently. Maybe they just meant part 2. Maybe they just meant part 2. But maybe they meant... do I say this question every week? I've terrible fear that I do this question every single week. Do I read the activities to prepare for higher education section of UCAS? I don't think we can get the data sent through to tutors. It's not something we make admissions decisions based on. I think we get the data. It's not something we're making decisions based on. I think we're maybe getting it in a better format this year. The data format's pretty weird because there's lots and lots of tick boxes. There's lots of people declaring lots of things. So the data is quite hard to actually look at the data. I think we're getting it in a better format this time. We might be able to look at it, but it's not an admissions decision sort of thing. Bhutan's quite a good flag, isn't it? Is that the one? I think Bhutan's great because it's one of the only 2 flags with a dragon on it. Nepal is also a good one. Someone told me once. Let's just do a quick, because we had a flag. I just want to fact check something that someone told me once. Yeah, I think this is something someone told me once, which I'll put on screen as well. There's this aspect ratio. There's this fact about the aspect ratio of the Nepalese flag. I have not fact checked this. I think I saw it on Reddit or something. Yeah, here it is. Which has got lots of square roots in it from trigonometry or something. Aspect ratios of the flag of Nepal. So there's an intersection between flags and mathematics. A-level mathematics, let's go. While also not being a counterexample because it's red and white and blue, which we agree is not how counterexamples work. We're good. On this MAT livestream, James realises it's not entirely fun to make fair, but is it a number 5 video? Oh, good. Kai, I said upvote by mistake, earlier by mistake. British flag theorem. Oh, how does that work? I remember the phrase. Something to Google. Other search engines are available. Other social media platforms where you can upvote things are available. Other YouTube channels are available. And if you want to continue watching a YouTube channel, you'll need to pick a different one because this one is no longer going to be live as soon as I work out how to switch it off. which could take any length of time. No, not that. That one. Thanks for watching. We've been doing primes and proof on the Oxford MAT Livestream. Next week, recursion with a computer science twist. See you then. Take care. Bye.